Hi folks, Astronomy Live. Tonight, I'm going to be webcasting Comet 46P. Sorry, let me turn down the music there for a moment. So I'm just finishing getting set up here. We're currently looking at the star Aldebaran, and I'm just getting everything set up with the camera. And once that's good to go, we'll start tracking Comet 46P Wirtanen. Alright, so for those of you just joining us on the Red's Rhetoric channel, thank you for watching. We're doing something a little different tonight. I'm going to be live streaming this on two channels simultaneously, both on my channel at Astronomy Live, thank you for joining me, and on Red's Rhetoric's channel. And I want to thank Red's Rhetoric for allowing me to host this on his channel as well tonight. So, for those of you just joining us, we're just getting set up here to track Comet 46P Wirtanen, which is making its closest approach to the Sun, basically today, December 12th by Universal Time. And then this weekend it will be passing close to Earth. News articles, some of them are getting a little bit wrong, some of them are just publishing facts that are, while true, are easy to miss details that lead to the facts being presented incorrectly. To speak about it more bluntly, basically there are some articles claiming that this is the 10th closest comet approach to Earth in recorded history. That's false. It reminds me a lot of the 2003 Mars debacle, where Mars was at its closest in human history, basically, in 2003, and the closest it'll be for a long, long time. But those articles kept getting refreshed every year, and they kept saying that every single year Mars was at its closest ever. They also made claims that if you stepped outside, Mars would be as large in the sky as the full moon, which is not true. So there were some statistics about Mars being as large in the eyepiece of your average telescope in 2003 as the moon is to your naked eye, and obviously that got distorted. So similar things happening now. Basically, this is the 10th closest comet approach that we know of in the last 50 years or so, basically since the dawn of the space age, where humans have been launching things into orbit. And so they took that and ran with it, and some media outlets are stretching that to mean closest in all of recorded history. Obviously, the last 50 to 60 years of human history is not all of recorded history, but that's where that's coming from. There have been a number of other comets that have made closest approaches to Earth, closer approaches to Earth. If you look at comets throughout human history that we've been able to track, basically there have been some astronomers who've taken historical observations of comets that predate modern telescopes, modern computers, of course. But looking at where those comets were in the sky over a period of time, over weeks and months, astronomers even 100 or 1,000 years ago could say it was in this constellation one week and then in another constellation the next week, they can figure out an approximate orbit. And doing that, they've been able to come up with approximate orbits for a number of historical comets, especially those in the last few hundred years where telescopes have been in use. And so there have been a number of closer approaches to Earth, some very close, that have occurred before the dawn of modern telescopes, modern photography, all of that. But this is nevertheless a very close approach by a comet, and we're going to track it tonight using my software, NeoTracker. This will actually be the first time I've been able to use the Python version of my tracking software to track a comet. So that'll be exciting and something new. So let me get the computer hooked up to the telescope here and get the software up and running for tracking, and let's go chase a comet. Alright, so stand by a minute here. I'm going to be checking on something here with the CCD. I'm a little concerned that we could be looking at icing here on the CCD based on this image. I did recharge the desiccant plug yesterday by cooking it in the oven. Basically, you have to suck out all the humidity from the CCD chamber in order to get this CCD really cold, below freezing temperatures. If you don't, if there's humidity, it can condense on the CCD and form ice crystals. So, I'm a little concerned I might be looking at that right now. I'm not sure if this is just dust on the CCD or is this actual icing. So I'm going to warm up the chip and wait for it to come up to temperature. Probably should have done that first. I just assumed that since I just recharged the desiccant plug that everything would be hunky-dory with that, but I'm not entirely sure that's really the case. If not, it's not the end of the world, it's not the end of the show. I can always just run it at a warm temperature so that there's no icing. But you get better signal to noise, you get better noise performance out of the CCD when it's really, really cold. So ideally, it'll be okay. It won't be icing, but I want to be sure. There could still be some humidity that the recharged desiccant plug wasn't able to take out. In the meantime, I'm getting Neo Tracker fired up and ready to go, so that as soon as I can get another image here, I'm going to go ahead and take another image. It's almost at freezing temperature. It's still sub-zero temperatures here with the CCD, so if there is icing, it will still be present. But there's also more noise. You can see how the image got a lot lighter, and that's because of the increased noise. I was at negative 25 degrees Celsius there a moment ago. Now I'm entering positive territory. So if I just change the exposure a little bit, it'll recalibrate with a new auto dark. We are now at positive 1 degree Celsius. I told it to let itself warm up to 10 degrees Celsius, just to be sure I cook off any small ice crystals that might have formed. And I just want to see what the image looks like. There's a few artifacts in the image that I know are around the area where dust is on the CCD, and there could be ice collecting on those dust particles. But if they retain the same appearance, then I know I'm okay. And I might be looking at ice. Excuse me. Should be taking a new dark frame, yeah. Yeah, I have a feeling I was looking at some icing there. Not only does it pose potential problems for the CCD itself, but it also causes everything to look blurrier. You get this nasty sheen over everything. And I was kind of seeing that. So, yeah, I'm just going to have to run it at warm temperatures. 5 degrees Celsius seems to be okay. I can just tell it maintain this temperature. Yeah. Yeah, that's better. I'm not getting icing. Okay. Well, we'll just live with that then. It's not a huge deal, but it would have been better if that wasn't the case. Okay, we're going to turn on auto-saving. We're going to call this 46P. And we'll start off with 60-second exposures. So, take that down. Put that up to 1 minute. Oh, I also should show you guys the camera control window just so you can see what I'm doing here. Let me add a window capture for that. There we go. And you can see my camera control window. Alright, now I'm going to go ahead and have Neo Tracker start moving the telescope to the comet. Or not. What happened there? Oh, that's not good. Okay, I didn't like that. Why did it not like that? Line split. I got an error while I was trying to parse the JPL file. Line 212. Okay. What's the deal? Oh. Somebody says my stream is buffering like crazy. Okay. That's not good. It should be. Alright, guys in the chat, let me know. Is it buffering like crazy over here? Let me know. According to OBS, I'm at green stream health. I should be okay, but maybe I'm not. Let me take things down a bit. Okay, so where were we? Alright, I'll worry about any stream issues later. Sorry, guys. I apologize if there's stream issues. I need to figure out what's going on here right now. So, oh, video output low. Okay, yeah. YouTube is reporting bad stream health. I don't know why. I can rectify that, but I need a minute. On it. Where is... Ah. Alright, I think I found the problem. At least with the tracking side of things, I think. Let's try this. Give this one more shot here. No? Split out of range. List index. What is going on there? Oh, I see what the problem is. I thought I told you... Oh, I think I know what I did wrong. Okay, I had the wrong file type selected. That's the problem. Okay, that was my fault. Problem exists between computer and chair, huh? Okay. We are tracking ourselves a comet, in theory. Okay. Now, I can attend to the other problems of the stream. Where is let's start taking a picture of the comet, and I'll be right back. Comet. We have a comet. Sweet. Pretty obvious where the comet is in the image now, huh, guys? Alright, stream health is my next priority. Let's fix this. Shall we? Where is... there's that. Should just be able to plug that in and take care of that problem. Okay. Done. Okay. Nope. Output 3000. Okay, that should hopefully, fingers crossed, fix the stream health problems. Better now? Better now. Okay, good. Whoa, what happened to the... Oh, that's weird. Okay. Yeah, I'm not sure what happened to the image there. That was like a screw up with the dark frame somehow. Okay, I'm going to take a fresh dark frame and see what happens there. Or, well, basically get it to reset. I fear this camera may be starting to have trouble. I've seen that kind of thing before, but never that extreme. Alright, so give it another few seconds here and we'll get a new image in. Also, the camera, the telescope is set up in altitude azimuth configuration, so there will be field rotation, but hopefully the comet will be stationary in the image as the telescope tracks it. Hey, looks like we got a satellite or something passing through the view, too. I see Kara in the Red's Rhetoric channel chat. That's some very nice CGI. Well, thank you. It's not CGI. Promise. You guys are watching me work through all the problems in real time here. Alright, I gotta put the telescope hand controller away. Done with this. Where did I put the case? Alright. That's better. Much better, huh? Make sure we're auto-saving. Yep. We are auto-saving. Good. Alright. Oh. That was a weird camera issues there. That's not good. That's not good. I may have to send this camera back for servicing. Oh dear. Oh. Yeah, there's something really wrong going on with the CCD right there. I've never seen it quite that bad before. I've seen little glitches from time to time, but never like that. Oh well. We will carry on. As long as the camera doesn't completely fry out, knock on wood. Ming Lord asks, what's the top slew speed on my Celestron versus my Mead? The Mead is 8 degrees per second. The Celestron next star is only 4 degrees per second. Okay, that image looks a lot better. No weird glitches on there, really. Maybe a little bit. There's still some weird column issues or something going on there. But not nearly as severe. I wonder if it's a problem of the cooler. It is running at very, very low power right now. It's not having to work very hard to maintain 5 degrees Celsius. It's a pretty cold night out here. I don't really want to shut the cooler off, though. Yeah, getting some weird noise issues at the bottom of the CCD, huh? It's strange. It's really not good. This is in altitude azimuth right now. Comet's moving fast enough in declination that I didn't think there would be too much advantage to doing the polar alignment tonight, because it's going to have to track. Super speed USB or wrong interlacing mode. I mean, this is an ST2000, S-big ST2000. It's just USB 2.0, and as for interlacing, it really shouldn't apply here. It's an old camera for sure. Yeah, just some persistent noise in the bottom of the image that just won't go away. It's acting really peculiar. Okay, that image looks normal. See, that's the way it's supposed to look. So these other images not looking so normal. So, what field of view? That's a good question. Well, I don't want to push the computer any harder than it's being pushed. I can astrometrically solve that later. I actually don't know off the top of my head what the field of view is with this telescope, and that brings me right into this disclaimer. This show is brought to you by an affiliation and sponsorship from Orion Telescopes, and this is with an Orion, being captured with an Orion ST80 telescope. And right now you can get free shipping on all orders $75 and up from telescopes.com with Orion Telescopes. If you go to the link in the video description of Astronomy Live, you can support my channel if you want to find a telescope or telescope accessories this holiday season. And I will post the link in the chat. So again, I want to thank Orion Telescopes for the sponsorship. So here is the link to our affiliate, Orion Telescopes. So I don't use the ST2000XCM CCD camera with my... That's weird. It won't let me put the link in my own chat. That's funny. It won't let me put the link in my own chat. Oh well, it's in the video description. YouTube's acting really weird. So, as I was saying, this is an Orion ST80 telescope. It's a pretty affordable scope, but it works well as a guide scope and as a wide field scope. And I'm using it with the S-big ST2000XCM camera, which I don't use it with too much. So I can't tell you off the top of my head what the field of view is. Let me see if I can look that up. I probably have that documented somewhere. Okay, that was one issue. I realize now that my encoding was being done by software rather than hardware. That may have been a problem. So hopefully it'll work better now with less buffering. Yeah, I think that the stream encoding is working much better now. Hopefully you guys are getting less buffering. Yes, this is a 80mm refractor. This is the Orion ST80. And if you want to support the channel, if you go to my Astronomy Live page where this stream is being hosted, you can find a donation link in the video description. Thank you for all of your support, everyone. And everyone who sends me a donation, I will be sending you a free copy of Sat Tracker and Neo Tracker. Neo Tracker is the software I'm using tonight to actually perform the tracking. Here, I'll share that window as well. And it's a very simple little program for tracking near-Earth objects. Nope, not that. I thought Neo Tracker. There we go. So I blanked out my own location there, but it's a pretty simple little program for tracking with either the LX200 that I have right now, or also with certain ASCOM-compatible telescopes. If your ASCOM-compatible telescope supports the move axis method, it will work with your telescope as well. And in that case, you don't have to even specify a COM port there, but that's for LX200 connections. You can move the object around in the view using the northeast-southwest buttons, or specify a set number of arc seconds that you want to shift the image as needed. And you simply stop tracking to track near-Earth asteroids and comets like this. As you can see, it's doing a pretty good job on the tracking tonight. Also, I've developed Sat Tracker for tracking near-Earth, low Earth orbit satellites. In theory, you could track higher altitude satellites as well, though I haven't really tested that with my software too much yet. But with Sat Tracker, you can see the space station up close, the Hubble Space Telescope, and a variety of other low Earth orbit satellites. So these programs are both available on GitHub already, but in order to get them to run, you have to install Python and all the various dependencies required to make them run. And it's quite a process. So for anyone who donates to my channel, I will send you via the email associated with your PayPal, I'll send you a link to download a free binary version of these programs so that you can execute them straight away without having to install Python or any other dependencies. They should just work right out of the box. If you are sending super chats on Red's channel, I'm going to try to keep up with that. It's a little hectic managing 2 channels at once here. This is the first time I've tried this. But if you send an email address with your super chat, I'll put you on the list to send that software. Otherwise, if you make a donation via PayPal, I'll send it to that email address. So, again, thank you for all of your support. Helps keep this channel running, helps keep videos like this possible. As you can see, I'm fighting with a little bit of hardware issues tonight, and this stuff is not cheap, unfortunately. So, that's what I'm dealing with, but thank you again for all your support. Yes, I am in Florida. That's where I'm viewing this comet from tonight. But I'm in a pretty dark section of Florida, so... Yeah, it may have dropped the resolution down a bit on my main Astronomy Live channel, and the version that's up on Reds, although it might be 1080p, it's actually overkill because it's really just mirroring this stream on Astronomy Live channel. So if it's 720p on Astronomy Live, it's really 720p on Reds, although it may display as 1080. And I did that to try to limit the amount of processing power required from the computer that's actually sending out the stream to YouTube. And the amount of bandwidth, because it seemed like that was what was causing my buffering issues. Yeah, Terry. So as I was trying to explain, basically, I don't know, it seems like it's potentially a bandwidth issue with the laptop. Although I've got it plugged straight into a router, it should have plenty of bandwidth here, but I was running into some buffering issues there. So the executable files, they're about 250 megabytes for the whole program. And if you don't want to donate, you don't have to, and the source code will continue to be freely available. You can download the source code and do it that way if you want to, but if you want to support the channel, I appreciate it, and I want to give back something for you guys that's useful and hopefully helpful. Yeah, so streaming fine now. Okay, that's good. So, in terms of what I'm imaging with, Tyler Crayson is just joining us. The camera is an SBIG ST2000 XTM. It's a one-shot color camera, which makes it handy for live streams like this where you want sort of instant gratification with color images, and also when tracking fast-moving objects like near-Earth comets. The optics are an Orion ST80 refractor. It's a pretty basic refractor, but good for wide-field views like this, and it's riding piggyback on top of an 8-inch Meade LX200 Classic. Now, with the LX200 itself, it's really overkill in terms of focal length for this comet. You really want a wide field of view to get as much of the coma as possible, so that's why I'm using the wide field refractor. But the telescope does have a very nice mount, which is capable of tracking this comet, so that's why the refractor is riding piggyback on that, and the tracking is being performed using my NeoTracker software. So, in the video description of both Red's channel and my channel for this video, you should find a link to my GitHub page, and if you go to all my repositories there, you'll find a repository called NeoTracker, and that's the program being used here. You can download the source code for free and run it yourself, but as I said, you'll have to install Python, you'll have to install a whole bunch of dependencies that it runs on, things like NumPy, what have I got here, PyFM I know I'm using, what else, JSON, geocoder, serial, Win32 compliant. There's a whole bunch of dependencies you have to install, and if you don't really know what you're doing with all that, it can be tricky at first, and it's just tedious anyway. So, like I said, anyone who donates tonight, I'll send you a free copy of the binary executable form, just a simple link to a zip file that has the exe and the full program that you can just run out of the box just by running the exe as a compiled binary. Do I have issues with atmospheric shimmering? Not really, and that's partly because we are running relatively long exposures here, 1 minute apiece. Technically 1 minute, 1 second. I bumped it there to recalibrate the auto dark. But basically, because you're integrating the light over a full minute of time, atmospheric turbulence no longer causes shimmering. Instead, it just sort of has a blurring effect on the image, where the worse the atmospheric seeing, the blurrier the image will look, but it won't appear to shift from image to image because you're integrating over so long that you're basically averaging out the atmospheric shimmering. You don't see the sort of high cadence twinkling that you do by eye. Your eye processes the light instantly, of course, so you can see very high frequency fluctuations in the color and in some wobbling of the star due to the atmosphere that you don't see in these long exposures because you're averaging over a minute of time, and those tend to average out to where you just have, you can kind of think of it as making the stars fatter, okay? You're basically reducing the maximum sharpness of the image. And that's why you need adaptive optics for deep space imaging. I do have an adaptive optics unit, though I'm not using it tonight. To use the adaptive optics unit, the SBIG A07 that I have, you have to be guiding on a star at a very high rate to cancel out the atmospheric turbulence as much as possible using a tilt-tip mirror system. But here we're tracking a comet that's moving through the sky at a relatively fast rate. So if we train the telescope on a star and we do auto-guiding and adaptive optics on that star, the comet's going to be smeared because it's moving against the stars. It's moving relative to the background stars. So I'm tracking on the comet directly and letting the stars trail instead. We're also getting a lot of field rotation here because I'm in altitude azimuth mode. So you see the whole star field appears to rotate over time, but the comet remains stationary because we're directly tracking on it based on its orbit. Oh boy, Zero says, Orphan Red proved that cameras don't work, since apparently human observation is the only thing that can collapse a wave function. We know this junk ain't real. I'm pretty sure you're being a Poe there. You're being sarcastic. I'm pretty sure. I wish I was 100% sure. It's kind of sad, the state of things on YouTube, that I can't be 100% sure of that anymore. But I'm pretty sure you're joking. Now, I did hear about this Orphan Red video. I think, was it Simon Dan or Conspiracy Cats? I forget who. Somebody did a debunk of it, and I apologize for not remembering who did it, but it was hilarious. I did see that. She was claiming that if a camera is completely unattended and there's no human watching the picture being taken, that it's not a picture. You can't take a picture because you don't have an observer to collapse the wave function of the photons. Okay, that's not how that works. But hey, if you want to believe that, then I guess all unattended security cameras are fake. And if you get caught on an unattended security camera, then you can go to the judge and say, it's fake, there was no observer to collapse the wave function, these pictures aren't real. Right? Should be able to get you off of any charge there that you get caught on security camera with, right? So, anyway. Is it dumb to ask why it's green? No, it's a perfectly fair question. So the comet is this greenish color due to the gases that make up the coma. So comets have a lot of icy material associated with them, and this icy material starts to vaporize as it gets closer and closer to the sun. And actually, this comet is at its closest point to the sun. So it has this supply of volatiles, and when most people think ice, they think water ice, but it's not just water ice. It's a lot of other volatiles that sublimate into gaseous phase at temperatures the comet reaches as it approaches the sun. So the gas around the comet that's producing this green color ranges from diatomic carbon to cyanogen. Sometimes you get some methane gas even, and some carbon monoxide, things like this, that are in solid phase when the comet is far from the sun, but as it approaches the sun, starts to outgas and kick off some dust off the comet and forms this coma. As these gases are ionized by the solar radiation, the ions can form a trail that forms the tail, one of the tails of the comet. Dust can form a second tail, and based on the kind of gas that makes up the coma, that determines the color of the coma. So, as I said, the green color usually denotes diatomic carbon and cyanogen gas. And yes, this comet is a short-period comet, and I believe you're right, Middle Slugs Master. I believe it has an orbital period of about 5 years. So it's got a relatively small orbit compared to long-period comets that can range in thousands of years, maybe even millions of years, some even hyperbolic, and leave the solar system never to return. And you're right, Area 85 restoration. Sublimation is how spacesuit cooling systems work. Exactly right. You have a porous, usually something like a porous water ice sublimator plate, something like that, that is designed so that ice will form and sublimate off gas that carries away heat from the spacesuit to dump excess heat overboard. I see Aiden is posting a link to, the Sky Live. I think they have a pretty good chart showing where the comet is in the sky. Thanks, Marvel Girl, for posting my link and link to my channel in Red's chat. Yeah, so this comet, even as closest to Earth, is still going to be, I believe, a few million miles away, and about roughly 30 times, maybe a little closer, than the Moon is to us. So, not exactly a super close shave, but closer than your average comet, for sure. And definitely close enough to put on a good show. Let me refresh my dashboard here on YouTube, trying to see what the status of everything is. Apologies if this causes some buffering issues here as it reloads. Or does that? Okay. Yeah, I heard about the Russians going on a spacewalk today to inspect the hole in the Soyuz capsule on the space station. That was kind of interesting. So from what I heard, what was the deal? They were... I thought they were expecting to see something they didn't quite see with the hole. I forget what it was. But I know they took samples and they're going to analyze it. And if nothing else, it'll give them data on spacecraft repair techniques, which is always good. Hey, Area 85. Yes, this is Astronomy Live. So I want to thank Red again for allowing me to host this stream on his channel tonight as well as my own. So I'm dual broadcasting on 2 channels. And if any of you guys are thinking about getting a telescope in the near future, if you are thinking about getting a beginner scope, I do recommend Dobsonian style scope as your first scope to get used to moving around the sky and learning your constellations and how to star hop and all of those fantastic skills. And Dobsonians give you a lot of bang for your buck. The bigger your telescope, the more light collecting area, the dimmer the object you can see. And so I was able to look through my 8-inch scope tonight and see this comet really easily through the eyepiece. So you really want a lot of light collecting area, especially for your first scope, and especially if you aren't planning to spend a huge amount on the telescope. Orion telescopes does make a wide range of Dobsonians. I've used some of them and found them to be good quality, and I'm not just saying that because they're advertising with me. I do have some experience using their scopes, and they, like I said, they make a nice range of scopes ranging from basic run-of-the-mill standard Dobsonians that are completely manual to push-to scopes that have digital setting circles where you have a computer device that's attached to the scope, and it tells you how much to push it in each direction to find the object you're looking for. And then they even have, I believe they do make some that have a go-to capability. So you can get quite a nice range of telescopes in Dobsonian form to suit your style, especially if you're looking for a first scope. And so if you follow the link that's in the video description of my page for this video, you can get free shipping on all orders, $75 and up, and it'll support my channel as well. So thank you, Orion Telescopes, for that. And even if you're just looking for an eyepiece or something like that, Orion makes quite a nice set of eyepieces. They also make some nice cameras. I've seen some advertisements for a new camera they've got out, a new deep space camera that looks quite juicy, a high resolution, very sensitive CMOS deep space camera. I believe it's called the G10, and I'm curious to see how that performs. I can't wait to see some test results out in the field with that. Hopefully after tonight I'm not going to be in the market for a new CCD camera myself. Now I'll probably will have to consider at some point, though, sending this camera back to SBIG for some servicing. Orion also makes some good autoguiders and guide scopes. So the scope that I'm imaging with right now, the Orion ST80, normally I bought this to use as a guide scope, where you have a CCD camera looking through a telescope riding piggyback on your main telescope. So it's a smaller telescope with a smaller CCD camera, just to guide on a star. And back when I was doing SLR imaging with a standard Canon SLR, single lens reflex camera, it didn't have any way of auto-guiding on its own, of course. It was just a standard camera that I was using for astronomy. And so that's why I got this scope, the Orion ST80, to serve as a guide scope, using a second CCD to be able to guide the scope. And it's good for that, but it can also get some basic images, wide field images like this, for comet close approaches and things like that. You can also find higher-end refractors on the Orion site if you're in the market for something with a little bit nicer optics to it. Windex Cleans Your Brain says, "Do telescopes speak English? Jaren told me I have to tell it what it is looking at." I can see why he says that, but no, that's not how that works. So I can see how someone can come to that misunderstanding. If you have a telescope like mine, like the 8-inch LX200, when you first set it up and align it, if you want to do automatic tracking, you have to tell it what it is looking at for 2 stars. You have to align it on a pair of stars. You could even do a 1-star alignment where you simply point it at a single star and tell it, this is this star, now you know your way around the sky. If you do a single star alignment, you have to have a very nice level telescope. You have to have done a very good job leveling the telescope and telling it your exact location. If you have a 2-star alignment, you can technically even get away with not knowing your location. With the LX200 I have, this is an older LX200 from the 90s, it doesn't have a built-in GPS system. It doesn't have any way of knowing automatically where it is on the Earth's surface. But if you tell it 1 star, say Arcturus, for example, and then you flew to a totally different star, maybe Spica, and you tell it, okay, here's Spica. Now you give it a 2-star alignment, it can figure its way around the sky, even if it doesn't know where it is on Earth. You can get a little better accuracy if you tell it where you are on the Earth. But I think that's what he means when he says you have to tell it what it's looking at. You have to initially align it. Okay, that's true for some scopes. It's not true for all scopes, and even my scope, I could turn it off and just go without tracking and just point it manually at things, and they would still show up in the eyepiece. I've done that before, especially with just planets and watching the moon. If I don't have power available and I just have the scope, I can throw an eyepiece in there and I can just manually move it to the moon or the planets and look at them. And with some scopes, you can even do tracking without telling it where you are or telling it what it's looking at. So if you have a simple clock drive telescope with an equatorial mount, you can have a German equatorial mount, it's very popular, and you align it parallel to the Earth's axis of rotation, and you simply turn on the clock drive. And it's literally a series of gears that just turns the telescope. And it doesn't know where it is on Earth. The gears don't have that programmed into them. And you never tell it what it's looking at. You don't have to. It just tracks at the same rate that the Earth is turning. And by doing that, it keeps objects in your field of view. So, when I was in college, we had a very large telescope. I think it was 24, 26 inches, something like that, at the Robinson Observatory in Orlando. And we had this big Schmidt-Cassegrain telescope. It was built, gosh, I don't know when, probably the 50s. It had a computer of sorts with vacuum tubes, but it didn't have any sort of go-to capability. And you didn't have to tell it what it was looking at. If you wanted to use the digital setting circles, where it would electronically know the coordinates it's pointed at, then you could tell it where it was looking to calibrate it. But you didn't have to do that. We almost never did that. When we observed that telescope, we'd usually just turn on the clock drive. And again, it was just a series of gears that turned the telescope at the same rate that the Earth is turning. And we'd go all night observing with that, observing everything from not just the planets and moon, but deep space objects as well. So, no, Jaron is way out of line there. He doesn't know what he's talking about when he says that telescopes require the user to tell them what they're looking at. Only some telescopes, and only for the purposes of automatic go-to capability. Ming Lord asks, so he bought the SDC 435 for SatTrack. Can he use a 50mm viewfinder and ZWO camera with SatTrack? Well, if you're using the ZWO camera for imaging, then yes, but you'll have to use your own software to do the actual imaging. SatTrack just provides the tracking. It doesn't do the main imaging through the telescope. It leaves that up to the user. The 50mm finder should be plenty enough. That should be fine with the SDC 435 camera doing the guiding. So you'll need a video capture card, of course, to hook the SDC 435 up to your computer. But obviously, if you didn't need the frame grabber, I can see why that would be attractive. But at the moment, it's only designed to work with cameras that will work natively with Windows. I don't think the ZWO is really intended for that. So I would recommend trying the SDC 435 to start with. Eventually, I do want to add, if I can, I want to add ASCOM capability for connecting to cameras. That should open the door to probably the ZWO and a lot of other astronomical style cameras. But at the moment, that's a future feature, creature comfort when I get that far. I want to make sure the basic functionality is all there and working first, and make sure that's well bug tested, of course. And if you go over to my forum, I've got a forum set up for stat tracker support and reporting problems and such. I'll paste the link to that in the chat so you can get to that. So it's teletrack.freeforums.net is the website for my forum. And I'm going to paste that in my chat here. So there you go. Yeah, I probably do give Jaren too much credit, but gotta try. Try to be nice, right? I don't know. If you guys have a chance, I highly recommend checking out the documentary Behind the Curve on Amazon. They do a fantastic job documenting the flat Earth movement from inside, and catch some rather incredible statements by certain very popular flat earthers, Jaren included. Does my mount work on a flat Earth? Well, not in equatorial node. It wouldn't work if the Earth were flat. I don't have it hooked up in equatorial node at the moment. It was something I contemplated, but just decided not to go with tonight. But later on, we'll be doing that. So if I polar align it, then no, it would not work on a flat Earth. Because I wouldn't be able to polar align it on a flat Earth, unless I was standing at the pole. I do have Direct Show Driver for ZW, so that might work. It might. Direct Show Driver might work. That sounds promising. You could try it. I can't promise it'll work, but it's worth a shot. Oh, I see. Looks like Zero gave a nice big donation. Thank you, Zero. And I saw your donation earlier, Ming Lord, as well, so thank you. Both you guys, I'll be sending you the executable file for my programs. Yeah, the part where in the documentary, Bob of Globebusters basically covers up the fact that they detected the Earth's rotation with a laser gyroscope and then tries to find excuses for it. Just amazing. I mean, a ring laser gyroscope's no cheap piece of kit either. I mean, that's way more expensive than this telescope. And the other ironic thing I noticed in that documentary is it appeared that Bob of Globebusters had an LX200 sitting in the background in his house. So, technically, he could be running my software right now watching this comet and live casting it on his channel. Somehow I doubt we'll see that. Why is there no tail? Ah, that's a good question. So, the tail of this comet is really hard to detect. It's basically in large part because it is a periodic comet, not a long period comet. And it's a relatively small one, too. The physical nucleus is actually quite tiny. I think somebody said it was about 680 meters in size, so it's not that big. So there's not a huge amount of dust coming off from that comet, not enough to produce a nice big tail. I think I can kind of tell where the tail is generally oriented in the image, sort of down and to the right, but it's more like a lumpy coma than it is a tail. Yeah, 1010 says, I watched Behind the Curve, and it's a sad movie to see how we lost intelligence to the flat earth because they were bullied by nerds. That was an interesting take on that, I thought. You know, these people were looking for acceptance and community, and they felt excluded from normal society for one reason or another. And so, you know, I always try to maintain civility on my Astronomy Live channel. And that can be difficult sometimes. I mean, I get attacked horribly in some cases. But I always try to maintain civility, and, you know, if people do want to wake up to the truth and realize they've been had by a movement like the Flat Earth, then I'm more than happy to accept them into the tent, you know? So these are things, you know, that you can investigate yourself quite easily in some cases and see this, it's simply not true. The Earth isn't flat. And there are lots of accusations of hoaxes and fakery and how everyone's in on it, SpaceX and all these other space agencies, not just NASA, you know, there's lots of people who launch rockets. I've done work with Exos Aerospace, and I've seen firsthand, you know, professional rocket launch up close. Now, it was a suborbital rocket, but it did have cameras on it, and, you know, at ground level, sitting on the launch pad, you can see out to the horizon out in the New Mexico desert. Horizon looks flat. The rocket launches. By the time it hits the peak and you see black sky all around you and a bright sun, guess what? The horizon looks curved. We had cameras on either side of the rocket, 180-degree cameras, so you can collectively produce basically a 360-degree view. You can look around. I've set it up in my virtual reality headset, and you can look all around, and you can see how the horizon looks perfectly flat, yes, when you're at sea level. But this thing blasts off. Actually, I think we were pretty well above sea level, but, you know, we were on the ground. Looks flat, sure. You blast off, you go up kilometers into the sky, start to get out of the atmosphere, start to look around the horizon, suddenly it doesn't look so flat. And it doesn't stay at eye level either. It does drop down as you get higher. So, I know for a fact it's not flat. I've seen the evidence of this firsthand, but, you know, people feel a sense of community in this flat earth movement, and they feel, for one reason or another, alienated by their teachers, by mainstream science, by people who are in the know. And so the problem is that you can argue till you're blue in the face based on evidence, facts, and all the rest, but at the end of the day, they don't believe it purely based on what they think they know. They believe it based on emotion and based on the sense of community. And that's why you see a very visceral reaction to anyone who does come out of that community. They treat them with utter disdain for betraying them. And so it's a very tough nut to crack, because it's one you have to, I think you have to take an approach that respects their emotional state, in addition to providing all the facts and evidence. And I don't even know if that's enough. Because you see in this documentary, you know, somebody like Jaron, who does an experiment that clearly demonstrates at the end of the documentary, it's clear as day. He says, okay, if this happens, that means Earth is round. Guess what happened? The thing he said that would mean Earth is round. So it's not that he hasn't done these tests himself, and it's not that he hasn't seen the evidence that it's round, but when confronted by that, he immediately protects his belief system by finding some way to try to write it off, right? And so you have that emotional protection that forces you to reject all evidence that proves you wrong. And I'm not sure how you ever get through to somebody like that. So I guess that's one I'll leave to the psychologists and sociologists. Anyway, back on topic. This comet's looking mighty fine. Ooh. Justin's building his own observatory for his C8 Celestron Edge C-Gym with his 14-year-old daughter. That's quite a project. Best of luck to you. It's a fine mount, too. Yeah, 00. It is a lot like the Planet X community, isn't it? And there, I think you find a lot of people who are dealing with a lot of issues that go way beyond astronomy. And unfortunately, some of them are even, I hate to say it, dangerous. And you really have to be on your guard. Because they will find ways to harass you that go beyond the bounds of YouTube or the internet in general, if they can. And it's just crazy. Whereas Flat Earth, even if you believe, it's not an end-of-the-world belief system. It's not something that, if you come to believe it with all of your heart, that you feel like jumping off a building and taking your own life or something like that. But if you seriously believe that Planet X Nibiru stuff, that the world's about to end next week because of this stuff, it can be quite depressing. And it does disturb people, and you will see comments constantly on some of these Planet X videos asking these people who purport to be experts on astronomy that, what am I supposed to do here? Where am I supposed to go to be safe? And I've known people in real life who were contemplating ripping up their family and moving out of state because they thought a comet was Nibiru and Planet X, whatever, that it was going to cause the end of the world. And they came to me because they knew I knew a lot about astronomy. They asked me, is this something we should be worried about? Because they were seriously thinking about moving out of state. I said, no, there's nothing's going to happen. And of course, this was actually Comet Alanin. And of course, it disintegrated. It was such a minor comet, it didn't even survive its close graze with the sun. It disintegrated. And I'm glad that I was able to put their fears at ease. But unless you know somebody in real life who you can trust on that subject, most of these people, of course, are told that anyone who is an astronomer, professional, or even amateur is not to be trusted. They're in on the conspiracy again, much like Flat Earth. But this time, the belief system leads you to believe that the world is going to end soon. And some of these people promoting this know it's fake. They know it is. They don't believe it themselves. But they will say whatever it takes to promote it in order to get the attention, in order to get the views, and get the income flowing. And they have to tell bigger and bigger lies to keep it going. And it just gets to ridiculous levels. So that to me is even more disturbing personally, just because it does lead to people really seriously harming their lives and the lives of their families, disrupting them significantly because they seriously are concerned that the world is about to end. So, yeah, that is a big problem. Where's the Roadster? What constellation Elon wants it back? That's a good question. I don't know what constellation off the top of my head. I think there's a website, a couple of websites out there that you can go to track it. I'm not going to try to load that up right now, but yeah, it's already past. I think it's already past aphelion at this point. Its furthest point from the sun on its first orbit. I know it's already past the orbit of Mars on its way out from Earth at this point, a while back. And so I think at this point it's probably falling back towards the sun. It's amazing how fast that happened. It seems like just yesterday I was at the launch. It was really cool to be able to track that thing as it left Earth. Have I ever heard of a tracking product called StellarMate? I don't think I have. Maybe if I saw it, I'd recognize it. Yeah, that's a whole can of worms there, isn't it, Busted Shark? Busted Shark makes the comment about Art Bell's show on Coast to Coast AM, how he made a fortune out of Y2K and Comet Hale-Bopp. So with Comet Hale-Bopp, I don't know how many of you remember this story. There was an amateur astronomer tracking the comet, much like we're doing tonight. Only there was a bright star near the comet, and he didn't know what it was. He thought it was a UFO. So he calls into Coast to Coast AM late one night. It says he's found a UFO tailing Comet Hale-Bopp. Well, of course it wasn't a UFO, but the damage was done at this point. Turns out there was a cult called Heaven's Gate who listened to that program, and they heard about this UFO, and they thought it was the sign they had been waiting for. They believed that a UFO was going to come by Earth, and I think they also had, I'm not 100% sure, I think they also had some end-of-the-world beliefs tied to it, where basically if they didn't evacuate the planet with this alien mothership, that they were all going to die. And so they had to go be part of the away team. No, seriously, they called it an away team. And they had to go beam up to the comet, or to the UFO. So I still remember waking up one morning and hearing the news that over, I believe, 30 people had committed mass suicide. It was the Heaven's Gate cult. They believed that in order to join the UFO, they needed to kill themselves by drinking poison, putting sheets over their heads, and wearing their Nike sneakers and their black uniforms. And so this is exactly what they did. So dozens of people died because of a false report of a UFO tailing Comet Hale-Bopp. Now, I'm sure that amateur felt horrible about that. I don't think he ever intended for that to be the outcome of his story. But it just makes you think that there's a lot of responsibility on you as an amateur astronomer to be not only truthful in your reporting, but to do your due diligence before you make an extraordinary claim. It doesn't mean you shouldn't be transparent in your observations. I've caught things before that caught me unexpected on live streams. But before you jump to the conclusion that it's the alien mothership coming to beam you up, you should do your due diligence and make sure that you rule out more mundane explanations first. I believe the amateur astronomer who made this report to Coast passed away a few years ago. I mean, this was a long time ago, but it still sits with me, and it makes me think that amateur astronomers have a certain responsibility to not only be honest, but to be diligent about doing their homework. Yeah, actually, so Sam mentions in my chat about don't drink the Kool-Aid. Actually, that even predates Heaven's Gate. That comes from Jonestown, I believe, where the Jonestown cult committed mass suicide as well, and on an even bigger scale. But that was before my time, for sure. That happened, I think, before I was born, but they basically drank poisoned Kool-Aid or something similar to Kool-Aid. Flavor Saver or something, I don't know, or some other product, but basically Kool-Aid. And they passed it out to all the members of the cult and had them drink it. There was another huge tragedy. It had nothing to do with astronomy, but nevertheless, an example of the damage cults can do. Yeah, and it's an interesting psychological phenomenon that people latch on to these Nibiru and end-of-the-world cults so easily. And I'm not a psychologist, I'm not a sociologist, I couldn't tell you the exact reasons for that, but I suspect it's got something to do with the psychological comfort and feeling like you at least know when the world is going to end. Especially if, I would imagine, if you've got a lot going wrong in your life, but even if you don't, uncertainty is never psychologically comfortable, and being at least certain gives you a sense of control. You can plan for the future if you know what's coming and when. And it also gives them a sense of specialty. They have special knowledge that no one else has. And I can see why that would be psychologically attractive. Why you'd want to believe that. It's much harder to admit that you don't know what's coming next year, next week. I mean, it's, I guess, scary, but it's true. A small asteroid could land on your town right now, and you'd have no warning. Even NASA can only track objects down to a certain size, and beyond that, there's no guarantees. Sometimes we find some of these small asteroids right before, even right after they pass by Earth. But they have to be practically right on top of Earth for our telescopes to be able to detect them. Dimmer than about magnitude 21, our surveys generally don't pick them up. So that means we can't detect them until they're practically right on top of us, where nothing could be done anyway if they were on an impact course for that particular orbit. And there's been at least 2 cases that I know of that an asteroid's been detected right before it made impact. And even if it had been on collision course for somewhere important, there's very little we could have done other than ordered evacuations. So, less than, 100 meters or so, you're probably not going to get any warning if it hits. Something like Chelyabinsk. And that was really quite a small rock, and it exploded midair, but the shock wave blew out windows and injured people. So, safety tip for asteroid impacts: if you see a giant meteor streaking gradually through the sky, leaving a huge smoke trail in its wake, don't stand by the window and gawk. The shock wave probably hasn't reached you yet, and it's not safe. When they say duck and cover, people always laugh, well, what's the point? Well, the point is, if you're far enough that the shock wave blows out the windows but doesn't level your house, you don't want to be standing by the windows. You want to be under a desk, somewhere that you have protection from the flying glass. So you should probably go hide under a desk or something if you see a giant meteor streaking through the sky. Of course, no one knew that, in Chelyabinsk. No one had any experience with that. Nobody was thinking in those terms. But when you see something like that, don't stop and stare. Get under cover until the shockwave passes. Fortunately, those events are very, very rare, and the odds of that happening again, very low. But if it did, like with Chelyabinsk, it's very likely we would have absolutely no warning, and that's not a comfortable thing to be sitting with, right? It's much easier to think, oh, I see this little star next to this comet. I think that's an asteroid coming towards Earth. I think it's going to hit my house next week. Well, at least I know it's going to hit my house next week, so I can plan for that. Don't have to think about paying the bills next month because I'm getting wiped out next week by this asteroid that I believe in. And then next week comes and it doesn't happen. And there's a whole interesting study on what happens then to some of these belief systems and some of these cults when their prophecies don't come true. There's a book called When Prophecy Fails that studied this from inside a cult that had an end-of-the-world belief, and the end of the world didn't come true, and the members suddenly shifted their beliefs to believing that they had averted the end of the world by believing in it. And then they started proselytizing based on their belief that they had averted disaster. And people needed to believe their cult because this was capable of preventing the end of the world. So, yeah. What is the largest asteroid meteor that we know of? Well, in terms of asteroids, the largest asteroid is Ceres, which is actually a dwarf planet. It was the target of the Dawn mission, right? I believe I got that right. So, I think that mission wrapped up recently, didn't it? Dawn Ceres. Yeah, it's retired now, it's shut down. But yeah, we've sent a probe to that asteroid to orbit it, map it, and study it. And so there's quite a few beautiful images of interesting features on this dwarf planet / asteroid. It's the largest body in the asteroid belt, and it was the first asteroid discovered. So on November 1st, 2018, NASA announced that Dawn had finally exhausted all of its hydrazine fuel, thus ending the mission. So it's now in an uncontrolled state around Ceres. So free NASA probe for the taking if you want to go out to Ceres. Did he delete the stream with with shooters? Not sure what you're referring to there, Amal. I must have missed something. Darren Marsh says he had a meteor bright enough to cast shadows the other month. No boom, but a nice trail of red debris. Yeah, I've only seen that happen a couple times. I remember one time quite distinctly at Chiefland Star Party some years ago during a meteor shower. We had a really bright flash. It lit up the whole field. It was a really dark field, moonless night, really dark location here in Florida. And everyone, whether they were looking in that area of the sky or not, saw the flash, and there was a collective let out over the whole field. And afterwards, yeah, you could see residual smoke or debris from it in the atmosphere. And I watched it in binoculars. I want to say it lasted for at least 10-15 minutes. I could see it in the binoculars, this smoke trail from this meteor. Stellar Mate. Okay, let me see what this is. Sam posted a link here to some sort of tracking product. The name kind of rings a bell. I probably should know what this is. Oh, yes. Oh, yes. Okay. Yeah, it looks like it's basically a Raspberry Pi that they put into a custom case. And they're using Wi-Fi or Bluetooth to connect your telescope or camera to your phone. I could be wrong about that, but that kind of seems like what it's doing there. They got a little observation planner, a capture tool. That's cool. Do video recording with it. Field rotator support. Yeah, it's basically a capture utility. Yeah, I can see the appeal of that. Can comets be trapped by a planet's gravity and become satellites? Well, maybe. My understanding is that Shoemaker-Levy 9 had encountered Jupiter before its final plunge into the Jovian atmosphere, and Jupiter's tidal forces tore it apart. So it had sort of set up a relationship with Jupiter, but of course it wasn't a stable one, and it ended with a comet impacting Jupiter. But I can see how under different circumstances maybe such a body could go into orbit around the planet instead. So let's see how we're doing here. Alright, folks, just to give you a heads up, I'm going to be probably wrapping up the stream in about 20 minutes or so. But I'm going to turn up the music here for a little bit and go check on the other computer. And maybe warm up a little bit. It's getting really cold out here. I might bundle up with another jacket here. But I hope you guys are enjoying the stream and these beautiful views of Comet 46P. Alright, folks, I'm going to start wrapping up here. I want to thank again our sponsor, Orion Telescopes. And again, if you visit the link in the video description of my channel, you can get free shipping on all orders $75 and up, and the purchases will support this channel, so thank you again for all of your support. I want to thank everyone who donated tonight, and I also want to thank Red's Rhetoric for hosting this on his channel as well. Thank you all for watching. I hope you enjoyed these views of Comet 46P, and you'll also find the link to the source code for NeoTracker, the software used to do all of this tracking tonight, in the video description both on my channel and on Red's channel. It's on my GitHub page, and it's called NeoTracker. So thanks again for watching, and clear skies, folks.